getting into talking about not just right triangles, but some special and very specific right triangles. The special right triangles that we are talking about today are known as 45, 45, 90s and 30, 60, 90s. Any guesses as to why a 45, 45, 90 triangle is called a 45, 45, 90?
Because there's two 45s and a 90.
There's two 45-degree angles and a 90-degree angle. 30, 60, 90.
Because there's a 60-degree angle, a 30-degree angle, and a 90-degree angle.
Exactly. These triangles are named after their angles, but the reason that we talk about them is because of the fact that they are so prominent that rather than always doing Pythagorean theorem, which you can't necessarily always do with these because you don't always have a side length, but one of the things that we do with these is we can solve for missing side lengths on these triangles with having much less information than what the Pythagorean theorem can do. Now, before we move into this, there's one other thing that we have to talk about before we get into the first problems, and that is, in a triangle, one of the things that is a theorem that we don't necessarily talk about a whole lot is the fact that in a triangle, the biggest side is always across from the biggest angle, smallest side is always across from the smallest angle, and medium is across from medium. Now, if you have the case where you have some congruent angles, and we did talk about this theorem back in Geometry A, if you have two congruent angles, you also have two congruent sides, the sides across from them. Across from a 45-degree angle is a leg, across from the other 45-degree angle is a leg, and so this is another important thing to know about these triangles, and we're going to get more into that when we flip the page. One of the most common mistakes that I see in regards to these triangles, though, is people not recognizing the triangles as these special ones. Or people over-assuming things and calling one of them one of these specials when they're technically not. So the first thing we're just taking a look at today is just making sure we can identify these triangles. So, this triangle right here, is it a 30, 60, 90, a 45, 45, 90, or neither of those?
It is a 45, 45, 90.
I only see one 45 though.
Yeah, but each triangle adds up to 180. 180 minus 90 minus 45 gets us 45.
Correct. If you have a 90-degree angle and a 45-degree angle, the last one has to be a 45. Good. So that is a 45, 45, 90. What about B?
60, 30, 90.
It's called 30, 60, 90, but you are 100% right because I have a 90, I have a 30, and then the last one, angles add up to 180. Subtract those two, it would be 60.
Your last one is none.
Why?
Because there is no right angle and there is no 60 degrees. We are only given a 30-degree angle.
Correct. And while that might look like a 90-degree angle, to the best of our knowledge, that could be an 89-degree angle, and this could be 61. So, you're 100% right. That is neither. D. 30, 60, 90.
Good job.
E. I know these are both 45. That one has to be 90 because angles of a triangle add up to 180. Last one.
45, 45, 90.
Why?
Due to the fact that the two angles are the same, or because the sides are the same, like the thing we learned in the 45, 45, 90. So the angles are congruent due to the fact that the sides are congruent.
Yes. It's got congruent sides, which means it's got congruent angles. So these two have to be the same. We also know they have to add up to 90 because that's 90. And they have to, all three add up to 180. So yeah. If you have a 90-degree angle in a triangle and there are two congruent legs, it's a 45, 45, 90. So being able to identify these triangles is one of the key features you got to be able to do. Easy enough? Yeah. Identifying them is fairly straightforward. You just have to make sure that you're not oversimplifying things. Now, as I mentioned earlier, these will allow you to solve for things. Starting first with the 45-45-90 triangle. The 45-45-90 triangle theorem states that in a 45-45-90 triangle, the hypotenuse is the square root of 2 times as long as each of the legs. Okay, so what that means, in a 45-45-90 triangle, we know that these legs are congruent already. And with knowing that, one of the things I can do is I can call one of them a variable, and the other one would be the exact same variable. I'm choosing k. There's a reason I choose k and not x or n. If you use x or n, it's not the end of the world. Just trust me, there's a reason. If these are both k, and this is a 45-45-90 triangle, that means the hypotenuse is k times the square root of 2. Now, this can help us in solving. Guys. This can help us in solving because now, rather than doing Pythagorean theorem, when I couldn't necessarily do Pythagorean theorem, I have the ability to solve for missing side lengths a different way. So, in order to do this, sometimes it's going to be a little bit easier than others. This first one is a very straightforward version of it. First thing I do is I recognize that it's a 45-45-90 triangle. Are we okay with that?
Yes.
Then, the next thing I do is I look for the side length that I know. In this case, it's 6. And I label that side length with the variable that goes on those sides. Since this is a leg, that means that would be k. Now, k is not something that I actually am going to, solve for in the end. It's not what I'm looking for. I'm not looking for k equals a number. I'm looking to solve for the variables x and y. If that is k, because that is one of the legs, this one also happens to be k. Therefore, the value of y is equal to 6, which we probably could have done without the k. The value of x, which is equal to k times the square root of 2, then becomes 6 times the square root of 2. I don't need the times symbol between. And that's what x is equal to, and that's solved. Some of these are really, really straightforward, like this one. Ones like the next one become a little bit more challenging, but it's all essentially about matching up those sides. I recognize it's a 45-45-90. Here's my hypotenuse, and my hypotenuse in a 45-45-90 is given by the expression k times the square root of 2. I take the side that I know and I set it equal to the expression that makes sense for that side. In a 45-45-90, legs are k, hypotenuse is k times the square root of 2. This creates a little equation that I can solve. This one, I didn't have to solve. This one, I do have to solve. Because if I know what k is, then I know what m and n are. Because each of these are simply k. So I take my equation that I know the number on, and I go to solve. I write my equation separate from the triangle, and I go to solve it. If I want to get k alone, and k is being multiplied by the square root of 2, what am I going to do with it? Not going to get rid of the square root, because the square root is not on the variable.
You're going to square it?
Nope, that's what I mean by not getting rid of the square root. We need to undo times. We're going to divide by the square root of 2. Now, keep in mind, the answers should be exact and simplified, so I'm not typing this into my calculator right now because my calculator is going to give me an ugly decimal. Square root of 2's cancel out right there. On this side, that's just 10 getting divided by the square root of 2. Now, in theory, I have k alone. The only thing I have to make sure is that k is simplified. Can the square root of 2 divide by any perfect squares?
No.
2 does not divide by any perfect squares. Can I leave square roots in denominators?
No.
No. To get square roots out of denominators, I multiply both the top and the bottom of the fraction by the square root that's in the denominator. In this case, square root of 2. 10 times the square root of 2. Does that simplify? No. Becomes 10 times square root of 2, and I write that out. Square root of 2 times square root of 2. Those are both in square roots, so they can multiply. And 2 times 2 is 4. So it becomes a square root, because they're both in square roots, of 4. 2, we already said couldn't simplify. The square root of 2, that is. But can the square root of 4 simplify?
Yes, it can.
What's it become?
2.
2, because it's a perfect square. By multiplying both the top and the bottom by a square root, by the square root in the denominator, you should always end up with a perfect square there. It's called rationalizing the denominator. So I end up with 10 square roots of 2 over 2. Can I simplify that further? Do the 10 and the 2 simplify?
Yes.
They both divide by
2.
2, leaving me with 5. The square root of 2 stays the square root of 2. Technically, in the denominator is a 1. Do we need denominators of 1?
No.
No. So that means k is equal to 5 square roots of 2. So we set up our little equation, the one with the number we solve, we simplify it, and then we go back to actually solve the variables we were trying to solve for in the first place. The variables we started with were m and n. Now m and n were the legs of the triangle, which are both k. Therefore, both m and n are equal to k, which is 5 square roots of 2. Now the 45, 45, 90 triangles, I'm going to tell you right now, they're a little bit easier than the 30, 60, 90s, just because the 30, 60, 90s does not have any congruent sides. But otherwise the process is going to be very similar. And then we're going to start mixing them together. So in a 30, 60, 90, it says the hypotenuse is twice as long as the shortest leg, and the longer leg is the square root of 3 times as long as the short leg. Now, in this triangle, this is the 30-degree angle. Up here is the 60-degree angle. Shortest side is across from smallest angle. Smallest angle's here. That means this side is the shortest side. Now in these triangles, since it refers back to the shortest side is going to be our k. It says the hypotenuse is twice that. How do you do twice something? What operation do you use? Multiplying by 2, which means the hypotenuse is 2k. And the long leg, that's this one, is the shortest leg getting multiplied by the square root of 3. In other words, k getting multiplied by the square root of 3. So, the process I follow. First thing, identify the type of triangle it is. Would you agree with me that this is a 30, 60, 90 triangle?
Yes.
I label my sides with their little k's, 2k's, k square roots of 3's appropriately. Now, I always start with the shortest leg. Which leg is going to be the shortest, the 10, the y, or the x?
The y.
The y. Now, it visibly looks the shortest, but the reason it's technically the shortest is because it's across from the 30-degree angle. So, that means this is the short side, and the short side, the variable is equal to is k. So y is equivalent to k. That means this right here is the long leg, which is equal to k times the square root of 3. And up here, we should know across from the 90-degree angle is the hypotenuse, and the hypotenuse is equal to 2k. So I've made the 3 little equations. Now I can only solve one of them, and the only one I can solve is the one that actually has a number involved. The 10. I pull that little equation aside and I solve it. 2k is equal to 10, and I solve for k. Divide by 2. K is 5. Now I plug k back into the other little equations and simplify as necessary. My other little equation over here is that y is equal to k, so y is equal to 5. Do I have to simplify that at all?
No.
No, that's it. My next little one is x is equal to k times the square root of 3. Therefore, x is equal to 5 times the square root of 3. I can write the times symbol. I don't have to, because it's implied. And that doesn't simplify. That's what we got. Problem B. 30, 60, 90 again. Which side's the short side? X. Therefore, I set it equal to what variable? K. Y gets set equal to what? 2k, because it's the hypotenuse. 9 gets set equal to? K times the square root of 3. I solve the little equation that I can. Which one? 9 equals k times square root of 3. It's the only one that only has k as a variable. How do I get k alone? We divide. You're never going to square to undo this, because it's always going to be multiplied by something at most. So we divide by the square root of 3. On the right side I get k, I'm going to move it to the left side. Equal to 9 divided by square root of 3. 9 divided by square root of 3. Can I simplify that?
No. Yeah. Wait.
Can't divide by 3 because one's not in a square root and one is, so they don't simplify together. I can't simplify the square root of 3 itself, but can I leave square roots in the bottom of the fraction? No, so I have to rationalize the denominator, which means multiplying both the top and the bottom by
3.
the square root of 3. By the square root that was in the bottom. This is what one of the things that we did during that e-learning day. 9 times square root of 3. 27, square root of 27, or something else?
9 square root 3.
It's just 9 square root 3. You don't multiply square roots with non-square roots. They just hang out next to one another. Over. Square root of 3 times square root of 3? They're both in square roots, so they do multiply. But what's 3 times 3? Square root of 9. I do that because now the denominator is a perfect square. What is the square root of 9?
3.
Wait, how did we get the square root of 9 from? Oh,
3 times 3.
why did it cancel out?
They're both positive.
So when you multiply square roots, you multiply the stuff inside, but it still stays in a square root.
Oh, okay.
But when you do that, what is going to happen when you multiply, you're going to get a square root of a perfect square, and the square root of 9 is 3. Is that what you mean by canceling out? That the square root symbol canceled out?
Yeah.
Yes, essentially it's gonna happen, I just did the step in between.
Oh.
Can I simplify further?
Yeah.
Square root of 3 doesn't simplify, but I've got two numbers here that are not in a square root, and they're in a fraction. 9 over 3, both divide by 3, and giving me 3 square roots of 3, technically over
1.
1, but do I need over 1?
No.
K is 3 square roots of 3. Is K what I was trying to solve for?
No.
Cool.
I needed to solve for it, but is it what I'm trying to get in the grand scheme of things? No. Okay, so I solved for my sides, I plug back in. This one is the one I solved. I don't need to plug back into that one. Ooh, X is
3 square root of 3.
3 square roots of 3, because X is just equivalent to K. Y is equal to 2K, so 2 times 3 square roots of 3. Can I simplify that?
Per chance.
Yeah, I can. I'm multiplying things. Does the 2 multiply by both 3's, the first 3 or the second 3? First, because it's not in a square root. 2 times 3 is
6.
6. Square root of 3 stays the square root of 3. Next page just starts to mix them together. We're not going to do every problem on the next page. The page after that starts to show some of the more complicated pictures that they can give you. So, on this page, one of the things that you might notice is you're going to get some problems that start with square roots on them. The process doesn't change, it just might mean simplifying looks a little different. First thing you do is you identify the type of triangle it is. This first one
The 45, 45, 90.
is a 45, 45, 90. Because I've got a right angle and I've got two congruent legs. On a 45, 45, 90, what are the different side length things that go on it? Like, what are the K's? Like, I know one of them's K.
K. K.
There's another K, and then there's a.
And the
K
hypotenuse
squared.
is K times square root of 2.
It's
Yep, I started to write the wrong thing. So that's the 45, 45, 90. I'm just going to write 45 for the reference. And then on the 30, 60, 90s, we don't need that for this one. What are the things that go on it?
That one is K, 2K, and then that
K
and K
times the square root of 3.
Good. And I wrote these in order from biggest to smallest. And that's the 30, 60, 90, which I'm just going to write 30 as a reference. You don't have to write that down at all. I'm just trying to save myself the headache. Yep.
Does it matter if we write 30, 60, 90 or like 60, 30, 90?
Technically, it's a 30, 60, 90. If you write 60, 30, 90, I know exactly what you're talking about. So, this one's the 45, 45, 90. K, K, and K times the square root of 2 are the different side lengths, and I wrote them here from smallest to largest. The smallest sides are this one and this one. And then the largest side is this one. That's the hypotenuse. The last one's always the hypotenuse. Which equation can I solve?
We can solve the 5 times the square root of 2 is equal to K times the square root of 2.
To get K alone, I do what?
We're going to divide.
Because it's being multiplied by things. Divide by the square root of 2. Now before, when we did this, we would write out something like 5 square roots of 2 over the square root of 2, and then we'd rationalize our denominator. But what happens in a fraction when you've got the same thing on top and bottom?
They cancel out.
They cancel out. They become a 1 technically, so this becomes a 5 times a 1, which is just
Straight 5.
5. So, that's as simple as k gets. Therefore, x is equal to
5.
5 because x was equal to k. And there was only one variable here. It was just written on here twice.
Go team. Math moment.
It is a math moment. I agree wholeheartedly. Try B and C on your own.
That's what I got.
What?
No, it says K.
Two.
Jacob.
You got the small shirt.
Yeah.
Right now.
Yeah, you stupid.
Nothing.
They gave me a small shirt to try. Just put it on.
Exactly.
Sweatshirt. Some connections in where it is crop top.
Yes, they're both in square root, so you can multiply them.
What? I put on a small shirt.
Wait, so Jacob, did you get X then for the
Uh-huh.
No, what'd you?
Oh, wait. Wait, I'll
Wait, what do you get for X, Jacob?
Okay, so taking a look at
You
B.
can't multiply two with the square
No,
root
we'll
of
see.
these.
I know I did it wrong.
Okay, taking a look at B. Which type of triangle is it?
Oh,
60,
60, 90.
30, 60, 90. So we got K squared is 3 and 2K.
Yeah.
Which one is K?
Oh, yeah.
K
That'd be
is
three.
the square root of
Square
3.
root
K equals square root of 3. Which one is 2K?
2K is
Y.
Y. Which one? Oh, not which one. The last one then, X is
K times the square root.
K times the square root of 3. The one I can solve is the top one, because that's the only one that has a single variable. Do I have to do a whole lot to solve that?
No, it's
No.
solid.
Y equals 2 times
Square
square root of 3. Can I simplify that?
root.
No.
No, but the only thing is you can write it without the times symbol. You don't have to, though. Okay, X equals, what's K?
3.
Square root of 3 times
Square root.
square root of 3. Can we multiply square roots?
Yes.
Yes.
Square root of 3 times square root of 3, square root of
9.
9. Square root of 9 is?
3.
Oh, so I got that one right.
Problem C. 45, 45, 90 on that one,
Yes.
which means there's two sides that are K. Which sides are K?
K is the square root of 2.
K is the square root of 2. I've already written it on the thing, that's why I'm writing here. So if K is the square root of 2, what's the formula for the hypotenuse of a 45, 45, 90?
It is K. Oh,
K,
yeah, it's K
times-
the square root of 2.
which means it's square root of 2 times square root of 2.
Yes.
4.
Square root of 4, which is
2.
2.
Whoa.
I didn't do that one yet, Jacob.
Okay,
Yeah.
No, my brain made that way harder than it's supposed to.
we're gonna skip over D.
Yes.
We're gonna talk quick about E and F. We actually have to talk about 2. I meant to skip over one of the other ones, but I forgot to. My bad. Okay. 30, 60, 90. Which side's K?
Yeah.
Which side's 2K?
3, 6, and 3 squared.
Which makes this one?
The K times the
Square root of 3. Okay, so this is the equation I can solve. 6 square roots of 3 is equal to 2K. If I want to get K alone, I'm dividing by 2. What's that simplify?
That is per chance. 3 over 1, or well, 3 times the square root of 3 over 1, which is just 3 square root of 3.
Yeah, those simplify. 6 over 2 is just a 3 in front of the square root of 3. Which makes Y 3 square roots of 3.
Yes.
Now X is K times the square root of 3. K was 3 square roots of 3, and I have to multiply it by the square root of 3 again. 3 square roots of 3 times square root of 3. That 3 stayed a 3. Square root of 3 times square root of 3 became a square root of 9. And the square root of 9 is
3.
3. What's between the 3's?
A times symbol.
What's 3 times 3?
3 times 3 is 9.
9. Now, last one that's on this page, you probably noticed is not a 30, 60, 90 or a 45, 45, 90 triangle. It's an equilateral triangle, making it an equiangular triangle. Equiangular triangles have angles of what?
They're like the same to each other.
They are the same, and if angles of a triangle have to add up to 180, and there's 3 of the same angles in it, each of those angles is how many degrees?
180 divided By
60.
3.
180 divided by 3 is 60. So, in an equilateral triangle, if you draw down what's known as the altitude, you create two congruent triangles, but not just any congruent triangles, two congruent 30, 60, 90 triangles.
Go team.
Will these be on the test?
Maybe. That's a 60-degree angle. This was H. This is 4. The bottom side, all the way across was 4.
2.
So it has to be 2.
Oh.
It does have to be 2, but why?
Because
Split down the middle.
it's split in half.
Because it split it into two congruent triangles, so this does have to be 2.
Indeed.
I want to solve for H. H is the long leg or the short leg?
It's the long leg.
Long leg, so that's the one that's the k times the square root of 3, which means 4 is 2k and 2 is k. Now I could solve either of those. Which seems easier?
The bottom one.
Bottom
Okay.
one.
K is 2.
Whatever.
H is equal to k times square root of 3.
It would be 2 times the square root of 3,
Perfect.
which we cannot simplify.
Correct. So, equilateral triangles. Throw down the altitude, and you got two congruent right triangles. Okay, now, the last page. On this last page, you actually might want a highlighter. I've got some up there if you want them. You don't have to have the highlighter. Okay, sometimes they're going to throw some more complicated pictures at you, like these ones where they put multiple triangles together. When they do that, I highly recommend you draw separate triangles. I've got one that looks like that. I've got one that looks like this, and I was a little aggressive on size. They don't have to be this big. I've got a 60-degree angle on this one, and there's an X here. There's a 45-degree angle on this one, and there's an 8 here. Our goal is to solve for X. Still under the same instructions we did on the previous page. In order to do this, when they're overlapping pictures like this, essentially I have to work through one triangle to figure out what I know and transfer that information to the other via the shared side. Now the shared side between these two, right here, on this triangle is here, and on this triangle is here. Knowing where that shared side is going to help you, because what you're going to do is you're going to take this triangle, which you know a length on, find the length of the shared side, put that shared number on the other triangle, and then go to work on that triangle. So the triangle that I know a length on this one is this one right here. I know the 8. And so the way I'm going to approach it is I'm going to ignore this completely and pretend this is the only triangle in existence. It's a 45, 45, 90 triangle. 45, 45, 90 triangles, the legs are k, the hypotenuse is k times the square root of 2.
Yes.
K, k, k times the square root of 2. I solve for k on the side that I can.
That's the side of the 8.
I plug back in specifically, I'm looking to find the shared side. That's the side I highlighted. So in this one, that means this is
8 times the square root of 2.
8 times the square root of 2. Once I do that, now I go to my other triangle and I mark down the side length I just found where it belongs. The highlighted side was 8 times the square root of 2. I highlighted the exact same piece. I highlighted the shared piece. So that is now 8 times the square root of 2. Now I pretend this triangle doesn't exist, and I work with this triangle. Now, when you do this, if you need to use a different variable than k the second time around, go ahead and do that. I oftentimes switch from k's to n's when I do the second triangle, or to some other variable. You don't have to. Which leg is the short leg? Okay, so that's, I would be k, but I'm going to call it n. This is the long leg, which would be n times the square root of 3. I don't care about it. It's not labeled with a variable, and it's not labeled with a number, and I'm not looking to solve for all the sides here. And then the hypotenuse would be n times 2. It's typically 2k or 2n this time. I solve the one that I can. I can solve this one. 8 square root of 2 is equal to 2n. Solve for n, I divide by 2. N is, simplify that.
Perchance 4.
2 over the square root.
4 times the square root of 2. Which means the thing I'm actually trying to solve for is x, which is 4 square roots of 2. So these ones require a little bit more thought process going into them, but is it really any different than what we did on the previous page?
No.
No, the challenge is making sure we're moving from one triangle to the other. I think I'm going to stop with notes right here. I will probably do this problem, so in case anyone wants to see another one, they can, but I'm going to do that after people start work time. That way if someone's like, I'm good on this, they don't have to. Our homework today is a book assignment. You'll be okay, I promise. 9.2. Today's the 28th. Our homework's due on the 3rd. We're on page 459. It is numbers 1 through 12, 25 through 27. Remember, the 9.0 worksheet's technically due today. Also, unfortunately, with our snow days, they've shifted things. The first day after we come back from our long weekend is a quiz. But that's the only thing happening that day. There's no lesson that day.
All right.
Just the quiz. I'm going to write the homework assignment up here too in case people are still copying it down, and I'm going to flip back to that other page for those who wanted to see that last example. If you don't want to see the last example, you are welcome to start working on the homework. And I wrote the homework assignment up here if you missed it. There's my shared side. I've got the triangle that looks like this one. I've got another triangle that looks like this one. Oh, that's a terrible drawing, but we're going to pretend I can draw. They share this side and this side. Okay, so I'm going to start with this one because this is the one that's got a number. It's a 30, 60, 90. That's a 60, which means that's the long leg. This is the short leg. K. This is the hypotenuse, which is 2K. This one's K times the square root of 3. Yes, you may. Okay. I'm going to solve this. 7 square root of 2 equals 2K. Divide by 2. And 7 over 2 doesn't simplify, so it's 7 square root of 2 over 2. Which is what this side is. That side's K.
What are you going to get on the next test?
And I'm going to put that here.
100.
Because that's the shared side. Now, I'm going to move on to this triangle. It's 45, 45, 90. Side lengths are K, K, and K times the square root of 2. But I'm going to switch to n's. So they're n and n and n times the square root of 2. So I can solve this one. 7 square root of 2 over 2 equals n times the square root of 2. If I divide by the square root of 2, they cancel here and they cancel here. N is equal to 7 halves. And x is just equal to n.